questions. Okay, great. Over to you then.
All right. Thank you very much, Matlub. All right. So this is joint work with Miriam Manchin at UCL and Politecnico di Milano, and Alex, who is at Université Paris-Saclay. And we're almost getting ready to submit this, so we would really welcome your feedback. Okay, so everyone can see my slides and hear me okay, I presume? Okay, great.
Yeah, all good.
So the question that we're trying to answer here is how and why climate risk, long-run climate risk, and in particular over the period 1500 to 1800, how that affected current in-migration in 8 European countries. Now, current is a bit relative here, but it's determined by our data set, which I'm going to talk about, by one of our data sets, which I'm going to talk about in a minute. And that covers, it's a very detailed migration data set, and it's only available for the year 2011. So that's our research question. Okay, in case you fall asleep, you're too bored, or at the beach, here are our results. Okay, so we find that climate risk climate risk is proxied. If you're asking yourself, well, what is climate risk? We measure it by variation in precipitation and variation in temperature over that period, 1500 to 1800. And what we find is that climate variation, precipitation, but not temperature, hundreds of years ago affects in-migration. Today, we find that the effect is negative, and then we find some evidence of a U-shaped effect, although again, sloping downward. And we find that the effect that we find is driven by rural localities, since climate variation was important for agriculture. So a lot of our story, which I'm going to go through in a moment, is going to center on the importance of climate risk for agriculture. And then finally, in terms of mechanisms, we provide suggestive evidence that this link between historical climate risk and in-migration today is driven by historical GDP per capita and population density. So basically, our argument is that climate risk decreases prosperity, and then that in turn decreases in-migrants in the past, and that link persists until today. Okay, so just to give you an idea of the distribution of migrants and how detailed our data is, we use 2 data sets, but the main one, as I said, covers in-migration in these 8 European countries on the map. And it's very, very detailed at the level of, I think, neighborhoods. We have 45,000 units. And so you can see that there's quite a lot of variation within the data. So, so basically anything that's red means a lot of migrants, and anything that's blue means a little migrants. And we can see that, what is this? I think Spain, we have a lot of blue dots, blue rectangles, and then in different places we have red and orange rectangles. So there's quite a lot of variation in terms of the share of in-migrants in that particular cell or locality. Okay, so what is our story? Does it make sense? All right, so I'm going to just start with some historical quotes here that we found in the economic history literature. So our story is going to be about the importance of international migration in pre-industrial Europe. And it was a particular type of migration. It was a seasonal migration. So basically, during times of so when migrants were needed to harvest, to do agricultural work in different countries, they moved, they did the work, then they would come back, but a lot of them would actually settle in the destination countries. So here's in 1607, this French Baron de Saint-Cyr asked, how could the Spanish work the land without the French if the French did not come to help and settle? Who would harvest if more troops of French did not come? And who would serve the Spanish in the fields and cities if these same French did not? So this is from Leslie Moch's book, the name of which I forget, but it's I think it's called Moving Europeans. Another important thing about people in Europe at that time was about 10 to 20% of women and men remained unmarried, and this facilitated them being able to move around. Compared to Asia, at the time where marriage was nearly universal. And so there's some other evidence. In 1840, there was a crisis in Europe that was triggered by poor yields. And so what happened was that seasonal migrants decreased, but local residents did not outmigrate either within the country or abroad. So seasonal migration was really, really important for this ecosystem. And that's exactly what this quote by Hofstadt illustrates. So each spring, the roads of Europe came alive as peasants streamed out of their villages and fell in with the bands from other villages to seek work in distant places. And the roads teemed again in late autumn when the workers began their homeward trek. From Spain to Russia, migratory peasants linked disparate economic systems. So this really, really illustrates how important these migratory routes were. And that's exactly what we're going to focus on in the paper. Okay, so what is our story?
Can I ask a quick question on the marriage?
Sure.
The 20% on Europe. Do you know anything about at which income level? Because it seems like it was the poor that were migrating for work.
That's a good question. I don't know. I think this was again from Moch's book, but no, I don't know.
If I just was trying to think who would that be.
I don't think it should matter for our story. But maybe you're thinking something different, because so the argument is that, okay, they were not married, so they were able to move around. But are you thinking something else that I'm not thinking?
So I think your story is that they were unmarried so they could move, but that would mean that this would have to be the poor people to stick with your story, right? But if the poor people
that's right.
And it was all the class that was, bachelors and bachelorettes.
That's right. They would stay at home. They wouldn't be moving around for work. Okay, good point. I don't know. I don't know, but I can certainly check. Thank you. Okay, so this is our story. So climate variation or climate risk is linked to crop yields. So the period that we look at is before industrialization. So agriculture is the main economic activity. So climate risk is linked to crop yields. That obviously determines the availability of food, and therefore the demand for and the supply of these temporary agricultural workers who moved periodically along these established routes. Now, demand for agricultural workers is going to vary, so it's going to increase in times of high yields in the receiving location. Remember, our focus is on in-migration, and the demand will obviously decrease when yields were low, as I showed you in one of those quotes or one of those examples from this 1840 food crisis or whatever it was. Now, the supply of agricultural workers. So basically, climate risk is important for demand. It's also important for supply. Now, if I'm an agricultural worker, climate risk is obviously going to feature in my decision about where to go. So low climate risk in the receiving location relative to the sending location would justify either temporary or permanent relocation for potential migrants and vice versa. Just one thing that I want to point out here is that this type of migration is very different from the typical migration that we think of, like the Borjas model, etc., where I'm a migrant, and today at this point I have to decide, I have to weigh in all the costs and benefits, etc., and decide whether I'm going to move to one place and stay there forever or for a long time. So these people move back and forth, and at some point they stayed, then they moved, and so on and so forth. Okay, so what are our hypotheses? Well, about the effect of climate risk on migration. Well, we argue that past climate risk has a significant effect on in-migration today, but obviously the overall effect, well, not obviously, but the overall effect is ambiguous, since it depends on conditions in both the receiving and the sending locations, and those interact. In our main data set, we can only observe, so this very, very detailed data set that corresponds to the picture that I showed you earlier, we can only observe conditions in the receiving location. However, we have a second data set based on genealogical data where we can observe, so we basically have information about the sending and the receiving location, and there we observe the same pattern as well. So the same results that we find with the first data set. Okay. Okay, so now, so what I'm arguing here is, okay, so past climate risk influenced past migration, and then there is another step in that story that past migration influenced today's migration. All right, so we cannot observe past migration, but we can observe, so basically what we observe is past climate risk, we observe today's migration, and then we can observe some other kinds of variables that could be intervening mechanisms. And there we can think of several mechanisms that might explain this persistent pattern between past climate variation and today's migration. So network effects, pro-migrant attitudes, as farmers had to cooperate to deal with climate risk. There's a paper about this that I'm going to talk in a moment, but basically it argues that in localities, so the Bugle and Durante argue that in localities where there was climate risk, trust developed as a way to cope with it. And so that could have evolved into pro-migrant attitudes. In addition, so in different places might have adopted different political or economic institutions. There could have been conflicts, right? Climate risk, okay? Conflicts could have followed that. Trade could have been a way to cope with climate risk. And finally, income or growth or prosperity broadly defined. And this is the channel for which we find evidence in our analysis, in our data. We test all of them, and then we find that income proxied by historical GDP and by population density seems to be the kind of the most plausible channel. Okay, so very quickly about the literature, as I already mentioned the Bugle and Durante paper. So basically there's a big literature on, or growing literature on, the importance of environmental factors on different kinds of economic behavior. Giuliano and Nunn, Anderson, colder temperatures in Europe led to more Jewish persecutions, and then GLO and Ozak have this paper where they find that climate had a significant impact on economic behavior, on all kinds of things, including smoking and time preferences. And then, so this is the first strand of the literature to which, to which our paper is related. And then there's another literature on climate variation and out-migration predominantly, not in-migration. And that's using more contemporary data. A lot of it is based on country-level data. So that's more on the, on the migration side. Okay, so what is our contribution? We have these new and very detailed data sets that allow us to look within the countries rather than across countries. A lot of the previous work, so there's a lot of work on climate change and different outcomes, and that usually uses only temperature and precipitation levels rather than variation as we do. So we use both in our regressions, and that allows us to capture the distribution of weather patterns. There's a very small literature on climate risk and migration in particular. And there is very little attention in the literature on the link between climate risk and in-migration, which is different, which we argue is different from out-migration. Okay, so I'm going to talk about the data unless there are questions. Okay, no. All right, so the first data set is from our first data set is from the European Commission. So we have information, so it's for 2011 only. It has information on the country of origin of the population in cells 100 meters by 100 meters. So we aggregate them to 0.25 degrees to match with the climate data. So we have 45,000 local administrative units, which is very detailed. And those cover, so that data covers France, Germany, Ireland, Italy, Netherlands, Portugal, Spain, and the UK. Then we have the climate variability data, temperature and precipitation. Oh, and I forgot to say, if you know the Bugle and Durante paper, I think 2021 Economic Journal. So our data is much more detailed compared to their data. So climate variability, we have data on temperature and precipitation. This is from this data, the European seasonal temperature and precipitation reconstruction. And then we have cells 56 kilometers, 56 kilometers times 56 kilometers. And then we have, in some of the specifications, we use, so basically what we do for each year, we calculate the standard deviation of temperature and precipitation, then we average that over the entire period, 300 years. And then we also split, we have different variation for growing and non-growing season over this period, over all years during the period for each cell. So for each cell, we're able to compute this climate risk measure. Okay, so the second data set is our historical migration data set, and that allows us to look at bilateral migration. Now, how do we do that? We have this data on people looking for their ancestors, which has been used before in the literature from Kaplanis et al. So 86 million people that look for their ancestors in an online genealogy website. So now what is good about that data is that we have the geolocated places of birth and death. And then what we can do is we can build, so first of all, we can match that to the climate data, but second, we can build basically a measure of migration. Is it perfect? No, but so we look at where that, so we look at a particular period. So I'm going to show you results with 100 years, but we tried different other periods. So we kind of try to approximate, approximately for how long would a person be alive. And then we see where that person was born, in which cell, and in which cell did they died. And so if they were born and died in the same cell, they didn't migrate. However, if they were born in one cell, but then they died in a different cell, then outside of that country, then they migrated. So that's our measure of migration. Now the Kaplanis data.
So you're missing anybody who went back and forth and ended up dying.
No, yeah, we cannot observe that. Yes, we only know where they were born and where they died. Yes, so we don't know if they went back and forth. And the other thing to keep in mind about the Kaplanis data is, well, obviously, it's not representative. The people who look for their ancestors, there's particular kinds of people that look for their ancestors on websites.
So it would be fair to say that you are kind of looking at the lower bound of migration, right? Because some people could have gone back. Like, you can't be overestimating, right? If I'm thinking about it correctly.
Oh, that's a good point. We do find a lower effect.
I mean,
and
we went on vacation and died on vacation, you would capture them as a migrant, but that's probably more.
That's right.
Unlike...
Well, I guess people probably didn't take vacations, in a different country at that point in time. But
like visiting family or something, you still could die somewhere else potentially. But if I am thinking about it right, I would say you might be kind of on the lower bound of the estimates, especially if your historical accounts say that people went back and forth a lot, that it was more of a circular migration. I would expect them when they get old to go back home, not stay where they used to work for the summers or something.
That's a good point. So what we do find, I'm going to show you the results with that. We do, I think. So the reason why we use this data set is so that we could do this bilateral gravity model of migration where we have information on the sending and the receiving location, because in the cross-country data, we only have information on the receiving location. But we find, anyway, I'll show you what we find. I think that's a good point, and I haven't thought, we've been a bit frustrated with this data, but I like how you're thinking, so I'll pick your brain when we go to that a bit more when we go to that table. Okay, so for the historical migration data, we can't add very many controls. The only thing that we can add pretty much is population density, which we calculate from that cell. Because, we have that from the, we know how many people there were in each cell, how many were there, how many were born, died, etc. So we can calculate that, but we can't calculate anything else. In the nice thing about the cross-sectional data, the 2011 migration data set, is we can include all kinds of control variables. And then we have as I mentioned, the average level of temperature and rainfall. We have elevation, we have latitude, longitude. We have access to water transport to measure, to proxy for trade. We have population density. We have land suitability. We have whether the location was historically a city or whether it was rural. We have attitudes towards migrants, trust empowerment, and I think I'm missing conflicts here. And we also have conflicts. So we have, that data set allows us to control for a bunch of stuff. Okay, so this is the precipitation variation. So blue, again, blue rectangles mean low precipitation variation, and orange ones mean high. For France, you'll notice that you know, there's some white cells. We don't have all the data for France. So you will see that the precipitation variability in terms of so I'll show you the temperature variability. So the precipitation variability is much higher. So we're thinking of standardizing the coefficients, but basically keep in mind that the precipitation variability, this is in millimeters, is much higher compared to temperature variability. And so, you know, that's going to affect the coefficients. So the temperature variability, so again, orange cells, high precipitation variability, and blue cells, low precipitation variability. Okay, so our first specification, this is with the cross-sectional migration data, the 2011 data, that allows us to look at in migration in 2011 as our dependent variable. So our dependent variable here is the share of migrants in cell C and region R. Then our main variable, our main independent variable is climate risk. So we have the standard deviation in precipitation. We have the standard deviation of temperature over 1500 to 1800. And then we have all these control variables, mean precipitation, temperature, land suitability, whether the cell is on a coastal region, on a river, distance to coast, altitude, area size, latitude and longitude, population density, total population in the cell, variable for city, all these kinds of things. And then we have region-specific fixed effects. I forget now which NUTS level it is, but it's one of the detailed ones. Okay, so here are the results with this specification, with the cross-sectional data. So what we find, so precipitation variability here on top. So the dependent variable is the share of migrants in that cell. And in total, we have a bit more over 7,000 cells. And so precipitation is negatively and significantly related. Sorry, precipitation variability, so climate risk proxied through precipitation variability is negatively and significantly related to the share of migrants. The effect size is not huge. So I was just calculating that this morning. It's between, so if we look at the mean, so the share of migrants, the mean share of migrants is around 7%. So it's like 0.6% relative to the mean and 0.8% relative to the median. The median is smaller. So it's not a huge effect, but on the other hand, we're looking at things that happened a long time ago. And I was a bit disappointed that it wasn't a bigger effect. So what we see here in the first column is that temperature variability is not significant, and neither is mean temperature, but mean precipitation is positive and significant. So more precipitation, more migrants. All right, in the next column, we include an interaction between, so it's the same specification exactly as in the first. We include an interaction between precipitation and temperature variability, and that's negative and significant. And we see this here. So there is some sort of oh, sorry, that's not this. This is the third column, sorry. So in the third column, we include precipitation variability squared and temperature variability squared. And we find this, we find that there is kind of a U-shaped effect of, so there is some nonlinearity in the effect of precipitation variability. Sorry. Okay, so our story was about the importance of agriculture. So what we do in this table is we test exactly that. So in the first column, so it's the same specification that we had that I just showed you before. And then what we do is we include precipitation variability over the non-growing seasons for crops, for the main crops in those countries, and also temperature variability over the non-growing seasons. And we see, well, they're not significant. So it doesn't seem that the effect is driven by non-growing season, which is in line with our story. And then in the next two columns, we look at observation. So we split the sample, only cells that are cities and only that were historical cities, and then only cells that are were historically rural. And again, consistent with our story, we don't find an effect of precipitation variability for the city cells, but we do find that the effect is almost the same or a little bit higher for the rural cells. So again, that seems to suggest that, you know, climate risk was more important for agriculture, and the effect seems to be driven by these rural locations. Okay, so now I'm going to talk about this genealogy data where people look for their ancestors online.
I'm sorry.
So
I just want to make sure I understand. So in your previous results, you're telling me the bigger the risk and variation in rain, the less current migration there is. So
that's right.
Is the story that like stable rain was like a stable, you know, job opportunities for migrants, so they kept coming and they may be settled and you know, establish these networks, but if there was more variation, they just never really got used to going there, so we don't see current migration?
Almost. So absolutely. So the higher the precipitation variability, the lower the share of migrants today. But we're going to argue that it's not because of networks. I haven't showed you those results yet, but yeah, it could be because of networks. But yeah, they didn't come because it was a risk for them to come, right? So they were also, well, there's two reasons. We can distinguish from demand and supply factors here. I just want to be upfront. But as I argued earlier, it could be either because of demand. Well, there's a lot of climate variability in our locations. We're not going to ask foreigners to come and work here in this place, right? Because we can barely, you know, it's just so much uncertainty. And it could also be a supply motivation, right? So I'm a migrant, I'm a potential agricultural migrant. I'm not going to go to that location because there's too much uncertainty involved as well. But yeah, the story
in the middle column.
Oh, yes, this is because it's interacted here. So precipitation and temperature variability here, they're interacted.
But it's tiny compared to the positive coefficients you're now getting on the main ones.
Yeah, that's true. Yeah, I think we need to standardize these. I think it's otherwise it's confusing. Yeah. Okay, column 2. I mean, that's not really critical to our story, the interaction actually. So yeah. Good point. Sorry, does that answer your question? Yeah. Okay, and then as I said, we find that these basically this negative correlation, or which we argue is effect, is driven by rural location. So it's driven by agriculture. So the story is about agriculture. Okay, so I'm going to talk now about the historical the data that allows us to look at historical bilateral flows. So here we run this Poisson's pseudo maximum likelihood gravity model that is used in the trade literature, but we can also use it for, in this case, for migration. And so as I said earlier, now, well, the good thing about this data set is we can include all kinds of fixed effects, and then we can look at origin and destination fixed effects and all this kind of stuff. So we can basically look at characteristics at the sending and receiving locations, which we couldn't do in the previous data. The downside, I already discussed that, you know, it's not representative, etc. We cannot really include controls except for population density in the destination, which we compute from the data itself. Okay, so our dependent variable again is the, and remember that here we compute, okay, so we have a different measure of migration here. It's not the same as before. So our dependent variable is the share of migrants from origin cell O to destination cell D at time t. And the share is calculated as the share of the origin cell population. So climate risk, VDT is the climate risk in the destination cell, calculated as the average climate variation in the past 100 years. I'm going to show you result with 100 years. We did other, so here we really need to standardize the coefficients in this specification, but it doesn't really change very much when we I think we used 50, 75, 80, something like that. Then we have origin time fixed effects. We have origin destination pair fixed effects, and then we have destination fixed effects. So the destination doesn't vary by over time. And then we also have population density in the destination that we computed from this data. And then the errors are clustered by destination, and the interpretation of coefficients, since I'm not a trade economist, I had to look this up. So it's semi-elasticities for variables that are, for independent variables that are not logged. And if the independent variables are logged, which is the case for population density, then it's just an elasticity, %. Okay, I don't know if it's very confusing, or I think people look very, I don't know if it's disbelieving or very concentrated. It's either one of the two. All right, so here are the results of the bilateral migration flows. So the good thing is that precipitation variability is negative and significant. The not so good thing is that temperature variability is also negative and significant as well. And the effect, so these are not standardized coefficients, but basically, so precipitation variability is about 15 times bigger compared to temperature variability. So even with that, even if we think about that, temperature variability seems to have a very, very much higher effect. So again, it's climate risk, but in the previous data set, we found that precipitation matters, and we have a nice story in our paper about why precipitation matters for agriculture, etc. And here in this data, we find that that they both matter, but it seems that temperature variability has a higher effect. So again, we run the same specification, so we have a negative and significant effect of precipitation variability. And then it doesn't seem that this U-shaped effect survives here in the third column, where we have squared. Well, it becomes anyway, it becomes insignificant in the third column. So, but temperature variability still stays significant. So there's something about temperature variability that matters in this data set. So, and then we have the interaction column. But I agree. I think thinking about it, I don't think this is that important. It's not critical to our story. Okay.
That looks fine because nothing flipped sides. In your previous table, you just had.
Yeah. Well, here there is. Yeah, that's true. This is insignificant. The precipitation variability
and it's negative
here.
Nothing changes direction.
It's not. Well, it's not significant, right? It's this one. So it's not significant, the interaction. So it's not significant in the bilateral data, which might be another reason to, get rid of it. Okay, so now, should I answer the question, Matlu?
Yes, please.
Sorry, I just saw this. So Madeline is asking, what if you examine the push instead of the pull? Climate variability in the origin instead of the destination. We can do that so we can't do that with the first data set, but we can do that in the second data set. So that's a good idea. So we were trying, so basically what we're trying to do is to use this historical bilateral flow data as kind of a robustness check for our main data set, but maybe that's worth looking at as well. So climate risk in the origin cell.
Because you could then sort of maybe compare what's more important, right? Whether it's the conditions in receiving countries or whether it's the conditions in the sending countries.
Yeah, absolutely. And then hopefully in the hopefully the destination conditions are more important, because that's the story that we have here in this paper. Okay, so I'm going to talk now about mechanisms, and here I had to abbreviate because they were not showing on the table. So, you know, okay, so the dependent variable, so this is like a, so what we do here is we have the same regression that we had earlier with let me go here. So we basically replicate this column 1, okay, by sticking all other kinds of independent variables one by one to see whether the coefficient changes. So that's what we do. Okay, so we start with past migrants. So we stick, so that's not the dependent variable here. It's a bit confusing, but basically that's the independent variable that we stick in the regression. Okay, so we start with past migrants or networks, and it doesn't seem, so it doesn't seem that the coefficient on precipitation variability changes a little bit, but by not too much. Same thing with conflict. So it pretty much stays the same. Distance, trade, it changes a little bit, but it changes a lot. So it's halves, more than halves, when we include GDP per capita. So here, this is historical GDP per capita. And also when we include population density. And then we have, then we have attitudes towards migrants. So if anything, this coefficient on precipitation variability becomes even more significant. And then we have, sorry, I can't see here, is institutions. So this is trust in parliament. That's our measure of institutions, and nothing really happens. So and those are measured today, because we don't have, so those are from the I think it's the European Social Survey. So those are attitudes towards migrants and institutions today. So we don't have historical measures of those, whereas past migrants, and these are from the family data, from the historical bilateral flow data. Conflicts are historical. Distance to trade, distance to trade is the distance to water or river, and GDP per capita and population density, they're historical measures. So we interpret that as suggestive evidence that historical precipitation variation or historical climate risk in the form of precipitation variation negatively affected income levels, prosperity, however you want to name it, and then that affected in migration in the past and then in migration today. And this is a table where we include, so this is the same table as before, but now these different mechanisms, potential mechanisms, are dependent variables. And so basically what we see is that precipitation variation, so if we look at the first column, there's no correlation between precipitation variation and past migrants. More precipitation, more climate risk, more conflict. So there's no effect on trade. So more precipitation variation, less GDP, less population density, although it's not significant. More precipitation variation, more trust in parliament, and this one I can see, and better attitudes towards migrants. So better institutions and more trust. And this finding, so we don't use generalized trust like Bigo and Durante, but this finding that more climate risk, more trust seems to be in line with what they find.
So what's the
okay?
What's the interpretation of that? Why would precipitation have an impact on trust, etc.?
You mean their story or?
No, but I mean, what's the interpretation of this result? The trust, the second to last column.
trust parliament. So this is not generalized trust. So in the Bugel and Durante story, it's more climate risk, more trust among communities in order to deal with it. They also argue that they were better so that kind of informal institutions in the form of trust then evolved into better political institutions, for example. So we could interpret it in the same way. So we're not really looking at, so our measures are pretty crude, although they do use also contemporary measures. So, it seems that it fits with this kind of story, that more climate risk, right? Better institutions today. We don't have measures of past institutions, but, it seems that better institutions today and more trust in parliament, in whatever, in institutions. But it's trust in parliament is probably...
That's quite a bit of a leap, right? I mean,
Sorry?
It's quite a bit of a leap in terms of that interpretation of, there are...
That's not our interpretation. That's the interpretation of Bugel and Durante.
No, but you have included in your paper, so I'm just saying that's quite...
Yeah, well, it seems to fit with what they argue. What are you thinking about in terms of a?
I don't know. I mean, how could it? We can talk later. I'm just kind of puzzled by it. But okay.
So I'm sorry, I'm still, I think, confused. So it says dependent variable is migrants in the tablet.
Oh, sorry, no, that's a mistake. No, it's not migrants. It's I thought I fixed that. Dependent variable is each of the mechanisms.
So this time it is the mechanisms.
That's right.
So if you said before that higher precipitation variation meant less migration, so now you're saying that basically less migration means better attitude towards migrants?
So there's nothing, so migration doesn't enter at all in this table. It's just, so what I showed you before.
I know, but before you showed us that the precipitation variation meant there were fewer migrants, right? Because there was higher climate.
That's right. That's the first thing that I showed you. Okay.
Right. So now if I take that information into the last table, if you're showing the relationship between precipitation and attitude towards migrants, higher variation meant less migration, and now you're showing that this higher variation also means that there's better attitudes towards them. So to me, that seems like we like them better because they're not here.
Could be. I think, yeah, I don't know. So these are, so these are from the European Social Survey. They're not great measures, I think, of either attitudes towards migrants or trust or institutions or anything like that. I think the historical measures are much better. Absolutely, I think it's puzzling. I don't know how we can fix that. I'm not sure that we have.
And I'm trying to figure out what this means.
Yeah,
like,
yeah.
This table.
No, I think that's a good point. That so precipitation variation means better attitudes towards migrants and more trust, but it also means less migration. I don't know.
In the previous table, like you kept saying that past migration is not important, but it is coming through as a significant predictor of the current migration.
Well, it's in this. No,
well,
it's here in this.
It is an outcome of participation.
Oh, sorry. So it is. Well, it's coming up. Yeah. So it's not important. Okay. So it's not important for explaining the effect. That's what I was saying. Okay. So it doesn't change the coefficient on precipitation variability. But yeah, you're right that it seems.
But it is predicting current migration.
So I don't know here. Is it the same? Okay. So I don't know here. Maybe that's something we. Oh, sorry. Here it doesn't seem to be significant. Well, this is calculated from the family data. So this is past migrants from the family data because that's the measure that we have from. So, but it might be good for us to check why it's coming. Oh, sorry. Why is it? So basically, why is it insignificant here? But you're saying it's significant in the other table. That's what you're asking, no?
Well, this one makes sense to me.
Yeah.
I think what you're doing with the next table is showing why these coefficients fluctuate. So all you're showing is the relationship between the GDP and the precipitation. So
Yeah.
there is a correlation. So when you include them, the coefficient's going to change.
Yeah,
But
so that's what I'm showing here, yeah.
Yeah, but that's not the same as saying that past migration doesn't matter for current migration.
That's true. That's a different statement. Is this what I said? If that's what I said, then that's not correct.
That's what I thought you said at the beginning, yeah.
Okay. No, I might have said that, but what I meant is that past migration doesn't explain the effect, this relationship between precipitation variability and current migration. It's not that it doesn't matter for migration today, it's that it doesn't, so I probably didn't say it right. So if I said that, if I said the other thing, then I didn't say the right thing. Okay. All right, so robustness checks, okay, so there's a bunch of stuff that we've done. The most important thing is, for those of you who are working on historical data, is this whole thing about historical. So Morgan Kelly has this paper about standard errors in historical studies and how you need to adjust for spatial correlation and things like that. So we spent like a few months trying to figure this out, and so we can only do that with the with the cross-sectional data, but basically the results go through with all of these with all of these Kelly/Conley adjustments. And if someone is interested, I'm happy to share all of the things that I found out about that. So that's it. So I'm going to conclude, unless there are any other questions. So basically what we argue is that climate variation, climate risk, which we use interchangeably, so precipitation but not temperature, hundreds of years ago affects in migration today. We argue that this is because of, so the effects that we find are due to rural localities, and that's in line with our story that climate variation was important for agriculture. So then we find suggestive evidence that climate risk reduced GDP growth, prosperity, which in turn reduced historical in-migration, and this persisted until today. And to the extent what we can draw any kind of policy implications, so there's tons of climate change and climate variability today, and if we can extrapolate, well, that will affect migration and in-migration in the very long run. In a lot of the literature, people use, so this is an old paper by Miguel that uses precipitation levels, and a lot of the work has been centered on precipitation and temperature levels. But what we argue is that precipitation risk actually decreases economic growth further. So Miguel, in this paper about, I think it was economic growth and civil wars in Africa or something like that. So precipitation levels, so he argues that precipitation levels affect economic growth in agricultural economies directly, right? But what we say here is that, well, precipitation risk may decrease economic growth further, both directly and also via in-migration. And then, policies that we might want to think about increasing or decreasing in-migration are mediated by long-term factors such as climate and geography. And I will stop here.
Okay, thanks very much. Any more questions? So the underlying thing is the economic the wage differential or whatever economic effect, isn't it? Or sorry, income effect, isn't it? Basically, if you have the potential to get a job, then and a higher wage than what you have right now, then, or in your origin country rather, then you will move there. I mean, that's the underlying thing. So I don't know how the extrapolation to the current situation. It's not per se that it's a higher temperature and people are leaving because there's a. So it's not climate effect, so to speak. It's more like an income effect. And so if you can get a job now somewhere, not necessarily in the agricultural sector, but other places, what it was in the 16th, 17th century is not the same industrial structure now. So the income effect is different now than it was then. So it's
true. Yeah, that's true. But we still have a lot of agricultural countries, predominantly agricultural. And I mean, yeah, I agree with you that it's probably a leap of faith extrapolating to today.
I'm just talking about the pull factor kind of story, because the countries that they're moving to. But yeah, I mean, so that's what I was trying to kind of get to, this thing that is primarily that income effect that is causing people to move, where climate is an indirect element of it.
Well, here the story is that climate reduces overall prosperity. There's just it's more about like the size of the about the uncertainty of the pie. It's not about right. So if I have a lot of climate risk, the size of that pie is I'm not going to know if it's going to be big or small. And if I'm deciding to move, well, if the size of the pie is small, there's no reason for me to do that. But also, if the size of the pie is small, the person who is offering the pie will be less likely to offer it. So I'm not. Yeah. Anyway, is that consistent with the wage effect? Yeah. Maybe you can use wage as a
if my business is growing,
shorthand.
If my business is growing, then I'm going to need workers, right?
Yeah. I think you're right. I think you can use wage as a shorthand for this kind of situation, unless I'm misunderstanding something.
No, that's exactly what.
Okay.
Yeah. Anyone else? Anything else? Okay, going once, going twice. No. All right. Thanks very much, Elena. Very interesting topic, and good luck with the submission, and hope it goes well. Hope some of the comments were useful as well. So if nothing else, then until next month.
Thank you very much, and thank you very much for the comments.